This lesson is focusing on geometric sequences. The two simplest sequences to work with are one that you would be familiar with, called an arithmetic sequence, and then the focus of today's lesson, called a geometric sequence. So let's do a quick recap of arithmetic sequences before we start. An arithmetic sequence goes from one term to the next by always adding or subtracting the same value. So for instance, if you have a look at example 1, we have 3, 5, 7, 9, and so on. We can tell this is arithmetic because each step adds 2. So let's have a look at example 2. We have 7, 3, -1, -5, and so on. This is also arithmetic because each step subtracts 4. The number added or subtracted at each stage of an arithmetic sequence is called a common difference, which is represented by D. Because if you subtract successive terms, you'll always get this common value. So let's move on to geometric sequences. A geometric sequence goes from one term to the next by always multiplying or dividing by the same value. So having a look at example 3, we have 1, 2, 4, 8, 16, and so on. And this is geometric because each term is multiplied by 2. So 1 is our starting value, multiplied by 2 we get 2. 2 multiplied by 2 we get 4. 4 multiplied by 2 we get 8. And so on. So let's write this out. So the number multiplied or divided at each stage of a geometric sequence is called the common ratio, which is represented by R, which I'll write shortly. Because if you divide successive terms, you're always going to get that same value. So here we have our starting value of 1. For this term, we have our starting value 1 and we're multiplying it by 2, or the previous term, which is 1. So for our next one, we have our previous term, which was 2, and we're multiplying it by 2. But we know that to get the first 2, it was our first term, A, which is 1 times 2. So 1 times 2 is this term here, multiplied by 2 again. Now if we look at 8, we know it's the previous term 4 multiplied by 2, but to get 4 we know it's 1 times 2 times 2 times another 2 to get 8, and so on. So we can use this to develop our rule. In general, we write a geometric sequence like this. So we always have our first term, which is represented by A, and then we have our second term, which is our first term multiplied by our ratio, which is R, and then our third term is going to be AR, and there's 2 lots, so squared. So if you can see the pattern, we're raising the power each time. So let's define our terms. So we have where A is the first term and R is the common ratio. So at each stage, the common ratio was raised to a power that was 1 less than the index. So let's have a look. This was term 1, term 2, term 3, term 4. But it's raised to the power of 3, raised to the power of 2, raised to the power of 1, raised to the power of 0. So we can use this to develop our rule. So we have A for any term n is equal to our first term multiplied by our ratio to the power of n minus 1. So let's use this rule for a question. So question 1, we have find the 6th and the 11th term to this sequence. So let's find the 6th term first. So writing down our formula, we have AN equals ARN minus 1. And we're going to let n equal 6, because we are going to find the 6th term. A equal the first term, which is 1. And R equal our ratio, our common ratio. So in this case, if we take our second term and divide it by our first term, we get our common ratio. So our ratio is 3. So let's sub this in. So A6 is equal to 1 multiplied by 3 to the power of 6 minus 1. After you put this into your calculator, you'll get 243. So if you kept going, this is our first term, second, third, fourth, fifth, then our 6th term would be 243. So let's now find our 11th term. So again, let's write down our formula. Let's state what we are going to sub in. So let n equal 11. Again, A is going to equal 1, and R is our common ratio of 3. So A11 is equal to 1 times 3 to the power of 11 minus 1. After you put this into your calculator, you will get 59,049. So I'm going to leave you with an extension question. So if AN is equal to 19,682, you find N. So this is going to require a little bit of algebra as well as your logs. Thank you for watching. The next video in this series is going to be on geometric series.